Hey guys, how's it going? So today I wanted to talk about where the formula for the area of a circle comes from, right? Kind of give a visual proof to go along with that. So as you probably know, the area of a circle is equal to pi times the radius squared. And in order to start by understanding this formula, right? It just kind of seems random, you take the radius, multiply it by itself, then by pi, right? Just kind of seems a little odd. So in order to understand this, we have to go back a bit to the area of, not the area, the formula of circumference. So the circumference is the distance around the outside of the circle, right? So the circumference equals 2 pi r. Also known, or you could also say pi times the diameter. And according to when you Google pi is actually it originated from the relationship between the diameter and the circumference. So it's the number that you have to multiply the diameter in order to get the value of the circumference. Okay, so now we know that. We can start with more of the visual part of the proof kind of thing. So, say we have just kidding, I'm gonna move the circle over here. So imagine we have like a wheel of rubber bands, right? Different size rubber bands. So say we have like this, right? And there's like a big rubber band on the outside, and as it moves more closer to the center, it gets smaller and smaller. Then imagine we cut those rubber bands from the center to the outside, right? So kind of like along the radius, we make a cut. And then we line all those rubber band strips up against this line, right? So it'd look probably something like this. I don't know exactly, I'm just kind of sketching it. Probably like that, I guess. And then you have all the strips in here. Right? So, and then, let's say, imagine we had another wheel, but this wheel had smaller rubber bands, thinner rubber bands, so you could fit more in there, right? So you'd have like really just like, I know it wouldn't look like this, but like a ton of these tiny rubber bands in there, right? And then we made a cut from the middle again to the outside, the radius, and repeated the process, lined it all up along this line right here, the same line, in order from the longest to shortest. It'd probably look really close to a straight line, but not quite, right? So then you have all the little rubber bands in here, right? So we have all those along this line. Now the next step is to imagine a rubber band wheel, as I call it, with infinitely small rubber band strips, right? So they're so small, infinitely small, thinner than this. So it's like kind of like a progression here. And so this triangle that you make, if you make a cut from the center to the outside or along the radius, they're so small that it looks like a straight line, And if you recognize, this is like a triangle. So now, let's think about how can we calculate the area of this triangle, right? So, and this still is a circle, right? This is a circle, this is a circle, this is a circle. So now, let's look back to here. What other value can we figure out, right? Because we already know this cut line along here is the radius, right? So everything here is the radius. We know we can figure out this value right here, because that is the outside of the biggest rubber band, So that's this value right here. So, and what else could that be called? Well, that's also the distance around the outside of a circle, or the circumference, right? So then that makes this is the circumference, and this is circumference as well, right? So we now know that this infinitely small rubber band wheel, I'm not gonna bother scribbling all that in, pretty much a more scribbled in version than that would probably just be like black ball. But there is all the strips and whatever. I'll color that in. So how could we find the area of this triangle, right? So the area of a triangle is the side times its side divided by 2. So that would be, for this, right, the radius times the circumference divided by 2. Alright, so that's a formula for finding the area of a circle. But could we maybe simplify this to maybe make it look a bit more cleaner? Which we can, spoiler. So we can substitute the circumference in terms of the radius, right? So from up here, we know that the circumference is the same as 2 pi times r. So substitute that in. It's for the radius times 2 pi r divided by 2. Right, so this in the parentheses is the same as the circumference. And now this is all getting multiplied together, and we can cancel out these 2's here, right? So pi times r equals pi r squared, which is where the area of the circle comes from, because the area of this triangle is going to be the same as this circle here. So yeah, just a pretty cool proof. So yeah, hope you guys enjoy it, and see you later.